Well, good evening and welcome back to the Johnson Space Center for our mission status briefing to recap today's first spacewalk of the newly extended mission of Atlantis. With us tonight to discuss today's work are Joel Montalbano, the Space Station Mission Operations Representative for STS-117, and Keith Johnson, the lead spacewalk officer for the mission. And we'll start off with Joel.
Well, good evening and welcome back again, like Rob said. As you know, we had a real successful EVA today. We went just over 6 hours, 6 hours and 15 minutes, and Keith will give you the details of what we accomplished today, but I can tell you that we did accomplish all the main objectives of the EVA. We were about an hour late getting out the door today, and as you may have heard, we had some problems with attitude control. One of the things that we wanted to do is, as we install the new truss element, we didn't want to have any thruster firings. And what we saw when we were controlling attitude with the ISS moment gyrodynes, we saturated. And basically, you had more energy in the system than the gyrodynes could support. So what happened is the control of the space station went to what we call free drift. We handed over attitude control over to the shuttle. The shuttle controlled attitude for about 30 minutes under the VRCS jets, the smaller jets on the shuttle. Once we got the ISS systems back in the configuration to take over control from the shuttle, we did that. Shuttle was in control for about 30 minutes. And then we handed over back to the space station control, and then we finished the activities, and we were all ready to go for the truss install. And then after that, we picked up on the EVA. We're not working any major issues. Like I say, we gained a little time in the EVA. We're trying to get the crew to bed as close as a nominal sleep time as we can. We may be about 30 minutes behind, but we're doing well. I believe you also heard earlier in the day that the mission management team has approved the extension for the mission, so we will add 2 days to the mission as well as a 4th EVA. I think we have one video of the radiator deploy that we'll show next. And the radiator deploy from today went nominal as we planned, and as the crew is trained, there were no issues. We're real happy with the hardware support today. Again, this was an excellent EVA, and I hope we'll be telling you that for the next 3 EVAs. We're real excited about what we saw today. And so let me hand you over to Keith, and he'll give you the details of what we did today.
Okay, thanks, Joel. Well, as Joel mentioned, we completed all the tasks. We got the solar arrays ready for deploy. We hooked up the utility trays, so we now have power out to the end of the S3, S4 truss, and then hopefully we'll get power back from that. We deployed the radiator. We started on the Sarge launch locks. We deployed one of the 2 drive lock assemblies. We can put the Aegis struts, the alpha joint interface structures, which change the load path out to the outer truss structure. All of that we did on the time that was we predicted and we trained to, and we're very proud of the crew for getting that done in the time that we had. We had several minor anomalies that we saw during the EVAs. The S4 keel pin has a bolt that we drive out to swing the keel pin out of the way to allow the solar array blanket boxes to swing out of position. And there was a high running torque, and when Jim Riley took the bolt out, he noticed that there were metal shavings. And then he'll swing the keel pin out of the way, and he put the bolt back in. He didn't have any problem reinserting the bolt, so we have no problem with that. We'll never use it again. So that anomaly was an easy one. We had a minor glitch with Danny Olivas's pistol grip tool. It shut down a couple times, but the good news is that he got all the way through the EVA using that tool, and it drove all the bolts that he needed to. When Danny Olivas removed the SVS target, we found that there was a missing spring on one of the bolts. The good news about that is that we didn't see anything leave, so we theorized that potentially there was no spring there to start with, so there's no issue there. That piece of hardware comes back inside again, and then it returns home, so we'll never need to worry about that. The other issue that we had was one of the TA clamps, and that's a clamp that holds a cable in place, had a lever bar that was bent. but Jim Riley found a way to get that hooked back on so the cable's where it's supposed to be, and that's all in good shape too. We had a little bit of difficulty getting one of the covers installed, and the good news is that when you send 2 EV crew members out there, one crew member's working on one task and one's working on another, the 2 crew members can combine, and with the teamwork that they had, they got the cover back in place. And so that was very good to have 2 guys out there, and we got the job done. I've got a couple clips that we'll show here. We'll cue up the first one. In this particular case, we have the crew members getting ready to install a foot restraint, and this is to get ready to do the MDM shroud. Okay. The next one is the last task that the EV crew members do on the mast canister. They release mast tip fittings. This is in preparation for the solar array deploy that we'll do tomorrow. There are 3 bolts that keep it in the launch configuration, and here you'll see Jim Riley driving one of the 3 bolts out. That's a nice zoom-in close-up of him with his pistol grip tool. And the last thing that you'll see is one of the cover bolts and the pistol grip tool driving that bolt loose. That is a cover that will come off and will remove a launch lock. We released 6 of the launch locks on this EVA, and we have the remaining 10 launch locks to remove on Wednesday's EVA. And that's the primary task that we have for EVA 2 is the deploy, or I should say the retract of the 2B array. We initiate the retract, and then we complete the removal of the launch locks on Sarge, as well as the launch restraints. And that's all I have.
Okay, with that, we'll take questions, and we'll start off with Mike Schneider.
Hi, Mike Schneider, Associated Press. Question for Keith. I assume that your team's going to be the ones who are working on the EVA for the thermal blanket. And if that's true, if you could just walk us through how you would develop that EVA, and will you be practicing simulations, and will you use astronauts on the sims, and who will you be using? If you could just walk us through that process.
Well, actually, the preliminary work starts out with what we call the Team 4. And Team 4 are people from my office that I work closely with, and they are experts in EVA, along with crew members and engineers that know all the hardware and the tasks. And what they do is they develop the techniques. They'll go to Building 9, you may be familiar with that facility, and they'll take mock-ups of the hardware and a big list of the tools that they can bring to their disposal, and come up with techniques to try and fix or constrain or whatever they decide is the appropriate way to work around this problem. They assemble a list of techniques, they kind of narrow it down, and then put a rough timeline together of what they think the task, how they're going to do it, and how they get there. And then they hand us on console that package of work that they put together, and we finalize the details about how we'll tether, how we'll get out to the work site, how we'll restrain the tools that they're developing for us, and how we'll put it in an overall timeline, and how we'll make the rest of the tasks fit together. So all that is work that has to be done. The Team 4 is still in the process of formalizing exactly what they want us to do when we go out and do this repair. And yes, there are crew members that they bring to bear on the task as well. So we've got people from all different disciplines that get together to work this together for us.
Have you all started any of the work on the mock-ups yet?
Yes, they have. We've got some, you may have seen earlier, John Shannon had a copy of the blanket itself with him during his press briefing. We have several of the same, and then we lay them out on a table and we practice different techniques and try and evaluate what way works best.
Folks have been in Building 9 at the mock-up facility since probably 3 p.m. today, and last I checked at 8 p.m. the folks were still kind of looking at different options, and and kind of just laying out what different hardware we have and what we have on orbit and how the best way to accomplish the task.
Patrick.
Yes, approximately how many bolts were unscrewed, and was there any debris produced today, either inadvertently or I guess, intentionally?
Well, I probably should have written that number down of the number of bolts that we drove, but it's probably on the order of around, I'd say, 100 bolts total. We did not generate any debris. We came up after STS 115, ISS 12A, where they did the similar tasks, and they had some inadvertent loss of some bolts. We came up with some techniques to assure ourselves that we would have far less chance of losing any hardware in the same manner. And because of that, we didn't lose anything today. But that's not to say that that won't happen in the future, but we think we've certainly limited the chances of it happening again. Todd.
Todd Halverson of Florida Today. I guess for Mr. Montalbano, could you go over the deployment sequence for the S4 array coming up here, why it's being done in stages and the strategy behind that? And I'm also wondering who is sending commands at during each stage of the deployment, whether it's being done from the ground or on board. And I have a follow.
Okay. Well, to answer your question, tonight while the crew's sleeping, we will deploy both arrays out to one bay, and that'll be ground commanded by the Falcon Council or the power specialist. And basically, you'll be unlatching and deploying out to one bay. We'll stay there overnight, and then tomorrow during the Houston day at approximately 10:45, we will deploy the 1A array halfway out, and then we'll let it sit in the sun and bake for about 30 minutes, and then we'll finish the deploy. Assuming that goes well, we'll go over to the 3A array, and that's scheduled to occur about 12:15. Again, we'll go halfway out, we'll let it sit in the sun for 30 minutes, and then finish the deploy. And all this is based on lessons learned when we first deployed the P6 arrays. We had some problems with the arrays sticking, and if you remember in the 12A mission late last year or fall of last year, what we did is we tried this where we let the array sit in the sun for about 30 minutes. That warmed them up nice, and they didn't stick together as they deployed, and we had successful deploy on both sides, and we're looking forward to the same tomorrow. Again, but the deploy both tonight and tomorrow is all ground commanded.
And you mentioned the P6 2B array and the trouble you had with deploying that back in 2000. How confident are you guys that the 2B array will actually come back in without any help?
Ideally, you'd like it to come in without any help. We're prepared, more so prepared than we were on 12A. We're taking the lessons we learned in December, and we're going to be ready to do a manual deploy or a manual retraction, as well as we're ready with EVA crew members to go out and assist if required. We have tools that we brought up both on the shuttle, as well as a tool that Sonny Williams made on board to help the array fold. You know, again, we're going to have the same problem where we talked about in December, where if you had a map that kind of sat on a dashboard over time and you had it sit for days in the sun, and now you want to fold it back, sometimes you have to help the creases so they kind of fold nicely, and we're ready to go give that a shot. Again, we're hoping it goes well, we're hoping it goes better than it did in December, but if it doesn't, we're ready to help it along.
Mark?
Mark Carreau, Houston Chronicle, and my question is for Joel Montalbano. Was there any prediction on the CMG that might happen, or was that sort of unexpected? And I wondered if that was due to the motion of the RMS or the station's robot arm with the truss on it, or there was just any sort of theory on why that happened when it did?
For each of the mission activities, we model what the dynamics we're going to see with the robotic arm and the payload. We were not planning to saturate this evening or earlier today, but as always here, we have all these procedures. Hey, if this happens, here's what we're going to go do. So it wasn't planned. When you're moving a large object out and at the end of the truss, you're going to get some additional disturbance. And that's what we saw today. We saturated, but we recovered. So not a planned thing, but we were ready when it happened. And as well, for the rest of the mission, the other activities, as we do robotics and any other dynamic activities, the team is ready for attitude control options if the CMGs can't support.
Just to follow up, would you suspect that there's less chance of that since you've installed the truss now and the arm won't be doing that, or is this something that might occur again? I mean, I guess I was just trying to get some feel for whether you'd have to deal with this during a spacewalk again.
Now you got the truss installed, you're in a more symmetric condition, so I expect you would have less occurrences of this.
Tarek, did you?
Thank you. Tarek Malik with Space.com and Space News, I think for Joel. Looking ahead at tomorrow's deploy, I was just curious about what that timeline is on once it is deployed. When do you expect, I guess, the first vestiges of power to start coming in from the array? What's the timeline on when it starts paying its own way in terms of energy?
We should have a good feel by by the end of the day, by the time the crew goes to sleep, we should have a good feel on what we're seeing out of the arrays. And so, like I said, by the time the crew's going to bed, we'll have understand what kind of power we're producing from the arrays, and as we go out through the evening, we'll know more. But again, remember, you can't rotate and sun track the arrays until you retract the 2B. 2B has to be retracted just under 20 bays for us to do the full rotation. And so tomorrow, after the activities tomorrow, you'll get a feel for the functionality of the hardware, but we won't be able to fully use it until we can retract the P6 2B solar array.
Reuters. It just wasn't clear to me. Is it the greater likelihood that the thermal blanket repair will occur on the 4th spacewalk or the 3rd spacewalk?
We're looking at both options. The Mission Management Telecom asked us, our Mission Management team asked us to look at both EVA3 and EVA4, and we're working those options. We plan to present options tomorrow to the MMT, but we haven't decided yet.
And if it's done on the 3rd, what would you do on the 4th spacewalk?
There are always EVA activities to do. We have get-ahead tasks to get ready for the next space shuttle mission, getting ready for the upcoming ESA partners and the Japanese partners. We have an oxygen generation system task, that a vent valve that needs to be installed that we have to do before we could operate the U.S. oxygen system. We have some cabling, get-ahead task to do, and Keith's probably got a handful of other ones.
I'm just going to let you run through all this. We had actually 4 EVAs worth of content before we even started the mission. So a lot of the 4th EVA tasks were tasks that, as Joel pointed out, seem to get handed from flight to flight to flight. When they don't get completed on a previous flight, they get handed over. And we had hoped to get all of those tasks done on the 4th EVA. So with the addition of this task, things will move out a little bit further, but we still hope to get a lot of the get-ahead tasks done.
Any other questions? Mark, follow-up?
Mark Carreau from the Houston Chronicle. I just wanted to follow up on the last question, and I guess I'm probably asking for a little review because I think you've talked this before, but it's about the oxygen generation system. If you were not able to do that vent valve work on this mission spacewalk, where would that fall? Would it fall to the station crew, or is that something you really want to try to do during this mission?
Well, Jim Riley did some extensive practice and preparation work for this, and he was also very involved in the development of the tools and the preparation to use those tools. So we feel that he's probably the best qualified to do the task. There's some techniques that he learned when the tool was developed and as part of the acceptance testing. It can be done by somebody else, but you're also working with a feed-through where if something goes, it gets loosened, you'd have more of a problem. So it's preferable to have him do it, but others could do it.
Okay, I think that may be all the questions we have. A couple of programming notes before we close. We'll replay the earlier post-mission management team briefing that we had on NASA TV. That'll be replayed at midnight Central Time, 1 a.m. Eastern Time. Flight day highlights of today's spacewalk will be broadcast on NASA TV at 1 a.m. Central, 2 a.m. Eastern Time, and will be replayed throughout the crew sleep period. You can follow the